Being able to write balanced chemical symbol equations with confidence is such a key skill if you're going to be successful at A-level chemistry. Chemical equations can come up in any topic of the course, and in an exam, you could be asked at any stage in the exam to write a balanced chemical equation for a particular chemical reaction. So it's a very, very easy way to pick up some marks, but if you get it wrong, it's also a really easy way to lose lots of easy marks. So it's really important that you're able to confidently write chemical symbol equations. I'm going to start in this video by talking you through how to work out the chemical formula for some key compounds, and then in my next video, we'll be looking at how to balance chemical symbol equations. We're going to start by focusing on ionic compounds. So ionic compounds, hopefully we already know, are made up of metal ions and non-metal ions. And there's a very easy way to figure out the chemical formula of an ionic compound, so long as you know what charge ions particular elements will have. If you look in the periodic table, then all the elements in group 1, when they form an ion, they will form a 1+ ion. So if we start with lithium, that will form a 1+ ion. Sodium will form a 1+ ion. Potassium will form a 1+ ion, and so on. Anything in group 2 will form 2+ ions. Anything in group 3 will form 3+ ions. When we get to group 5, when they form ions, they tend to gain electrons instead of losing them. So now they're going to have a negative charge. I should say that group 4 don't often form ions because they have 4 electrons in their outer shell, and they don't necessarily lose or gain electrons, they would rather share. But group 5 then, because we're gaining electrons, they're going to form ions that have a 3- charge. Group 6 ions, they gain 2 electrons to form an ion, so they'll have a 2- charge. And group 7 ions will gain 1 electron when they react, so they will have a 1- charge. Going to the middle of the periodic table then, where we have the transition metals. So transition metals are a little bit unique. They can actually form different ions. Now in an exam, they will indicate to you what charge ion the metal will have in that chemical reaction or in that compound, and they will do that by using Roman numerals. So I've put a few examples here. Copper 1, then, the 1 being in brackets representing the Roman numeral, that tells you that it has a 1+ charge. So copper 1 will have a 1+ charge. You can get copper 2, that will have a 2+ charge. Iron, you can get iron 2, meaning it will have a 2+ charge, or you can get iron 3, meaning that it will have a 3+ charge. So if you know how to work out the ions of those elements there, that will make your life so much easier. And then there's a list, or there are some common ions, again, that it would be really useful and helpful to you if you could learn and memorize these ions in this box here. So writing chemical formulae for ionic compounds, you can remember this really nice, simple, easy rule to do that, and it's called swap and drop. And when I'm saying swap and drop, I'm referring to the charges of the ions. So we'll look at sodium bromide first, and as an example, I'll go through a couple of examples. So sodium is in group 1, so its ion will form a 1+ charge. Bromine is in group 7, so the bromide ion will form a 1- charge. Notice that some of the ions, their names change when they're an atom and they form an ion. So group 7, atoms all end in fluorine, chlorine, bromine, iodine. When they become ions, their name changes to fluoride, chloride, bromide. Again, you do need to be aware of that. So to work out the formula for sodium bromide, I simply swap the numbers over of the charges, just the numbers, don't worry about the positives or the negatives. So I swap the 1 and the 1 over, which essentially leaves me with Na1Br1, and when we're writing chemical formula, we don't need to include the 1s, so it will simply be NaBr. So the formula for sodium bromide is NaBr. Magnesium chloride, different because magnesium's in group 2. So magnesium will form a 2+ ion. Chloride ions have a charge of 1- in group 7. Swap the charges over, so the 2 will swap with the 1 of the chloride, so we'll end up with Mg1Cl2, but remember we don't leave the numbers high when we're writing chemical formula. We have to drop them down, hence the swap and the drop. So it actually will be MgCl2. So that's why magnesium chloride has a formula of MgCl2. Lithium sulfate. Lithium is in group 1 plus. Sulfate ion is SO4 2-. So now I've got to swap those two numbers over. So I swap the 1 and the 2 over. So I'm essentially left with this. Okay, but we don't write the charges in our overall chemical formula, and we don't leave the numbers at the top. Again, we don't write number ones in chemical formula either. We don't need to. If there's no number, we know that there's one of them. So there's the chemical formula for lithium sulfate. Final example I'll go through is zinc nitrate. So zinc, transition metal, technically, sorry, no, it's not a transition metal, but it has a charge of 2+. And nitrate ion, 1-. Swap the two numbers over, so the 2 swaps with the 1, like so, but then we have to drop the numbers down to write the correct chemical formula. Now, if I left the chemical formula like that, NO32, that is incorrect because it's suggesting that there are 32 oxygens. We haven't got 32 oxygens, we need 2 nitrate ions. So to give us 2 nitrate ions, or to represent that in a chemical formula, we have to put the brackets round so that we know we have 2 of the NO3s and not 32 oxygens. Now you can't always apply the swap and drop rule if you don't have ionic compounds, because covalent compounds, for example, where you just have non-metals, they will not contain ions. So with covalent compounds, you just need to try and learn as many as you can. Some common ones, some obvious ones: carbon dioxide, carbon monoxide, sulfur dioxide, all your alkanes, your alkenes, so methane, CH4, ethane, C2H6, but remember alkenes and alkanes have a general formula that you can use to help you figure out the chemical formula for those. I've also included here then just some common compounds that would make your life so much easier if you could learn and memorize them. So we have some acids here that you can learn and memorize, which will help, and some common bases here. And then I've also made a list for you of the diatomic molecules. So diatomic molecules basically means you've got 2 atoms bonded together, and there are many elements, as you can see listed, where they don't exist as single atoms, they exist as 2 atoms bonded together, so diatomic molecules. So when you're writing these elements in a chemical equation, they have to be written diatomic. Thanks for watching. For more chemistry tips and revision, hit subscribe, click on the like button, and check out my Instagram page using the link below.